This will be the second part of the Exponential Applications series. I will be focusing on the exponential growth formula, which is A of t equals P times the quantity of 1 plus R raised to the T power. So what you want to do, or my strategy, is to count the variables and account for them. So I have A of t, P, R, and T for a total of 4 variables. So as I mentioned once before, A of t represents your future value, or the amount after time. That's how I like to look at it, A of t. Sometimes it will be shown as just A, and that's okay. P, present value. So what's occurring now, or your initial amount. And it doesn't even have to be money. It could be, like in our examples, we're going to be talking about population. So a future population, or what's going on right now in the population. R is your interest rate. While you're actually showing the work, you want to convert it to a decimal. When you get your answer, you want to convert it back to a percent. T is your time in years. So if you had 6 months, you would want to show it as 6 out of 12, because that's representing 6 months out of a year. In our first example, we're using this exponential growth formula throughout this video. Let's read what the word problem says and determine what we're looking for. So in 2008, Claire, Trevor, and Daniel lived in a town with a population of 8,200. They researched and found that the population grew by 2.3% each year. Ruth asked if they could determine what the population will be in 2020. So what I want to do is, first, like I said, the first thing you would want to do is figure out which formula you're using. But for this video, we already knew. So you're looking for keywords like grew, increased, or something to that effect, some type of growth. That will tell you that you're going to use this formula. The next thing I do is I look at the question, or what am I trying to determine? And it's usually towards the end of your word problem. So she wanted to know if they could determine what the population would be in the future. So after time. So that means that we're actually going to be looking for A of t. So A of t, that's where I'm going to put my question mark. P would be my initial population, which is 8,200. My rate is my interest rate, if we're talking money, or the percentage in this case of which something grew. We have to convert it to a decimal, and it is 2.3%, but we have to get rid of that percent sign. So it's going to be 0.023. And all we did was move the decimal over 2 places to the left, 1, 2, and we put a 0 placeholder and got rid of the percent sign. That's how you convert it. For my time, I wasn't given a specific year, so I have to do the work. I'm trying to find what the population will be in 2020. Well, it's started in 2008. So I'm just going to take the difference between those two, and that will give me my time, which is 12 years. So now I would want to go and find each variable, and I want to place this information in that order based off of where the variable is located in my formula. So I don't know A of t, so I'm going to go ahead and leave that as A of t. I know that P is 8,200. My formula says to multiply that times the quantity of 1 plus. My rate is 0.023, and I'm going to raise that to the 12th power. Anytime that I have a variable isolated by itself, all I have to do is put everything that's on the other side of the equal sign in my calculator the way that I see it. So let's do that. We're going to go to the calculator, and we're going to type in 8,200 times the quantity of 1 plus 0.023. And then we're going to raise that to the 12th power. We are talking about a population, so I'm not going to round it, but it may come back and bite me later. I'm just going to leave it as 10,772. Probably should do 73, but I'm just going to, let's just work with that and see what happens here. So A of t is going to be 10,772 people, because we're talking population. So now I'm going to use the same scenario just like I did in the first video, but I'm going to show you how to find the other variables. So we just said that A of T is going to be 10,772. So I'm going to go ahead and put that in the formula where it is A of T. So that's before the equal sign in this case. And over here, I'm just collecting my data. I like to keep it organized. And I noticed that I'm looking for P this time. I already have everything else. When your formula looks like this, or your equation looks like this, what you want to do is go to your exponent and you want to simplify it. So when I simplify that, go back to our calculator here, I am going to take the parentheses 1 plus 0.023 and raise that to the 12th power. I only want that part. And that's going to give me, and I want to go out 4 decimal places. So I'm going to bring down this 10,772, set it equal to 1.3137. Let's go back and make sure. Yes, that's what the answer came out to be, P. Now what I want to do is I want to divide both sides by what's stopping P from being by itself. So 1.3137. And what I do to one side, I have to do to the other. And now I'm going to just switch them around. It means the same thing. So P, and I already know the answer up here, is going to be, let's go to the calculator for those who need to see it. I'm going to take my 10,772 divided by, what I typically do is take the whole answer. So I'm going to go to second, the negative sign, which will copy that answer that's already in the calculator, and hit equal. So here it's showing 8199.5. Normally I would not round it because it's people, but in this case, for consistency purposes, I'm going to go ahead and leave it as, I'm going to round it to 8,200. So that's what my P is. You can also use the calculator. I showed you this once before. If you wanted to, you could take this portion before you even did any work and go to the Y equals button in the calculator. It's telling you in your table when Y equals 10,772, P, which we're going to have to change to X for our calculator table purposes, would equal 8,200. So you would have to go to X where it's 8,200 and you would see that. So this is what it looks like. Oh, sorry. Yeah. Hold on. Go back to my work. Go to the calculator. So if I go to Y equals, and this time I'm just putting the right side in, which is that X, because I can't put P in, times 1 plus 0.023 raised to the 12th power. And on the left-hand side where it says Y sub 1, that has to equal 10,772 in my table. So I'm going to go to my table, second graph, and I notice I have these little numbers where Y is like, it's the highest number on this screen is 19. Well, I need to get to 10,772. So to change my table start, I go to second window, and I already know the answer. So I'm just going to just grab something that's close to it. And that's where I want my table to start. So now if I go to second graph and I look down, let's go over to the right, under my Y column, I'm looking for 10,772. So this is here, it's 10,773, unless I look down at the bottom, then it's 10,772. So it really just depends. You could probably take either of these answers. So 8,200 is more accurate though. So let's go ahead and change my table back to just something reasonable. Okay, so that's another way that you can actually determine whether or not this is correct. You can just go and check it in your table where Y is equal to the number that's out front of your equal sign. Moving on. So this time we said that P was 8,200. We're going to go ahead and put that in our formula. But now we're looking for R. We already know R because, again, this is the same scenario. I'm just showing you how to find the different variables. The first thing you want to do in this case is you want to divide both sides by what's stopping your exponent from being by itself. So that's 8,200. And when I put in the 10,000 divided by 8,200, which we just did a few minutes ago, we ended up with 1.3137. And on this side, I have 1 plus r raised to the 12th power. So now what I want to do is get rid of this exponent. The inverse of getting rid of an exponent is going to be to take the root of it. So I'm going to take the 12th root of both sides, and that allows me to go ahead and get rid of the 12th power over there. Now let's go to the calculator. In the calculator, if I want to get out of the screen, I hit second mode, which above mode says quit, clear all this out. And what I want to do is type my index, which is the number on top of the radical, hit math, and then the number 5. Now it tells me the 12th root, and then type in my answer, 1.3137. Or I could have typed in the entire answer if I kept it on my screen. So once I hit equal here, I'm going to round this to 4 places after. So 1.0230, that's what we're going to do. So the 12th root of this number is 1.0230. And now that I've gotten rid of the radical on this side, I just have 1 plus r, the square, the 12th power. I just have 1 plus r. And now I want to subtract 1 on both sides. And when I do that, I end up with r. I'm just going to swap it around. R is equal to 0.023. But since we're talking about the rate, again, I have to convert it back to a percentage. That means I'm going to move this decimal over 2 places, and I'm going to add a percent sign. So what that looks like is R is equal to 2.3%. Again, we already knew this from our first scenario. I'm just using the same scenario, showing you different variables. Let's go to T. So for T, that's the exponent. That's what I'm going to try to find here. I'm going to do the exact same thing I did a few minutes ago. I am going to divide both sides by what's in front of my exponent, which is 8,200. What I do to one side, I do to the other. We've already done the math in the calculator, and we have 1.3137 is set equal to, and now I can go ahead and combine this to 1.023 raised to the t power. At this point, I could go on my calculator and put this under the y equals button, and then where y in the table is 1.3137, then that is going to be my t. So if I remember, I'll go and show you how to do that. But if I am trying to manually do this, I want to change this to a log, rewrite it. And what that will look like is my base of my exponent will now be my log's base. So log base 1.023 of 1.3137 is equal to t. Put this in a calculator. Let's do that. And you can't use this button. That means log base 10. We want to actually put our own base in. So math, and you can scroll all the way down until you get to A, which says log base, or you can just do math, alpha math. It means the same thing. Oops, I did it too much here. Let's do that math, alpha math. And what I'm going to put in here is 1.023, move over and type in 1.3137, which is what we had here. Let me just make sure. Yep. And enter. So that tells me my time. Well, I want to round that up to 12 years. And again, we already knew that as well. So 12. Now, what I was saying a few minutes ago, if I could either at this point put this part in my y equals right here. I can go to y equals, clear that out, and put the part that I highlighted, and then go to my table where it says y is 10,772. That would give me 12. Or I could wait until I got to this part, and under my y equals, let's type this in. So that's what we're going to do. We're going to type in 1.023, and instead of raising it to the t power, we're going to raise it to x because my table has x and y. So go to second table, and I'm looking for where is y equal to 1.3137. So going back here, I already know the answer. So 1.317, and I can also look down here. That means my x, which is really my t, is 12. So that's another way that you can actually do this problem if you wanted to use your calculator. Let's go to this problem. This one says, Manicah and Ian work in a scientific lab and have observed that bacteria can multiply rapidly. They noticed when they started with one bacteria, it doubled every hour. DJ entered the lab and wanted to know how many bacteria would have formed by the end of one day. So that's a lot. What you want to do is you want to look for keywords. Doubled tells me that something's growing. So I know I'm going to use the exponential growth formula, which is what I have here. Now I just have to figure out what they're looking for. So when he entered the lab, he wanted to know how many bacteria would have formed by the end of the day. So that means in the future. I am looking for A of t. That means the other variables are given inside of my word problem. I just have to find them. So they noticed when they started with one bacteria. So that's my P, that's present. That's what they started with. And they said the rate was that it doubled every hour. So I know that that's going to end up being 2. Well, technically it's going to be 1 plus 1 right here. And what's left over in the parentheses is 2. So make sure you understand that. My time is by the end of the day. So here I have to pay attention because the bacteria doubles every hour. So I'm going to have to convert the day to hours. So how many hours are in a day? 24. So now I have all the information I need to go over and set up my formula. I'm trying to find A of t. P is 1. And this is where I said be careful because doubled means that only 2 will be left over in your parentheses. So if you wanted to write like 1 plus 1, just so you know that that's really 2, you're accounting for that 1. And now you're going to raise that 2 to 24. So in your calculator, A of t is going to equal, you really don't have to put the 1. I'm just going to do it just to show you the formula set up. And this is your answer for how much bacteria will be left at the end of the day. That's a big number, right? So that's going to be 16,777,216 bacteria. That's the answer there. And we definitely don't want to try to use that in a calculator because that's a huge number. Well, you can't go to the table anyway for that one. All right, the next one says, Egypt, Jacollby, and Jonathan went to a class at the local wildlife preserve. Their instructor, Ms. Niera, explained that the population grew to 25,515 rabbits after 6 years. Over that time, it was documented that the population of rabbits tripled each year. The students were curious about the number of rabbits that the wildlife preserve started with. So again, you're looking for keywords. The keyword here is it tripled. That means it's growing, which means I'm going to use my exponential growth formula. So now what are we looking for? The students were curious about the number of rabbits that the wildlife preserve started with. So that means what did they initially start with? So they want to find P. That means that this was a future value. So the population of rabbits grew to 25,515, which is my A of t, at a rate of triple. So again, this is one of those cases where you can either write 1 plus 2 because your parentheses has to just have 3 because triple means 3. Time is going to be the 6 years, so 6. I find where the actual variables are located and I just substitute it accordingly. So A of t is 25,515. P is what we're trying to find. The formula says to multiply times 1, the quantity of 1 plus 2. In our case, we're going to just change that to 3. Let's just make it easy. So that's tripled, and then raise that to the 6th power. If I ever have the variable next to my exponent, I want to simplify the exponent first. So that's what we're going to do. Go to the calculator. 3 raised to the 6th power is 729. So we're going to go and bring down everything else. So 25,515 is equal to 729, but we have a P here. We're trying to find P. So what we're going to do is divide both sides by what's stopping P from being by itself, which is at 729. When we do that, and I like to swap them around because I like my variable on the left, but it does not matter if you keep it on the right. So now I'm going to go back. 25,5, oops, let's clear that. 25,515, is that correct? Divided by 729 will tell me how many rabbits I started with. 35. So 35 was my initial count of my rabbits. So again, for those people who want to know how to do this in the calculator, if I go to the calculator, I'm going to the Y equals button and I'm putting in the right-hand side. Instead of using P, I'm going to use X. So let's go to my calculator. Y equals, if something's there, clear it out. I'm going to put X in the place of P, and then I'm going to do parentheses 3 to the 6th power. What I am looking for is in my table, Y should equal 25,515. So if I go to second graph and I look at my numbers, well, I see at 15, it's only 10,935. If I'm trying to get to 25,000, let's just estimate that, I don't know, we already know the answer, but let's just use 30. So go to second table, and when Y is not quite where we want it to be, we want it at 25,515. So we're just going to keep going down until we see it. So right here, I see 25,515, or it can be close. So that means that at 35 years, which is X in the table, but we understand that it's really P here. I said years, I'm sorry. The initial amount of rabbits is really P. So that's how you can find it. So when P is 35, Y is 25,515. So there's multiple ways to do these problems. Subscribe and thumbs up.